Remote sensing is now in the age of data exploration. However, the ability to interpret the imagery is not sufficient for the rapid data growth, creating a gap in timely interaction extraction. Therefore, there is an urgent need to quickly and currently extract valuable information from the massive remote sensing data. The significant progress has been made in the remote sensing images interpretation, largely due to the breakthroughs in AI large models and high performance computing. Integrating remote sensing, big data, cloud computing, and AI into cohesive data computing application service framework presents a highly comprehensive service solution, unlocking the substantial for the improved image cognition and practice use. However, there are challenges for the image analyze. The first one is for the characteristics of the remote sensing images, which are the density of images seen and also the multi-scale. The second one is from the challenges of the target features. It includes the difficulty to collect the data, the spatial temporal multi-scale variation, the arbitrary orientation, small target size, and the dense targets. For the compared to the other image data sets, the intelligent interpretation data sets not only have a smaller sample size but also exceed limited scene diversity and incomplete coverage of the sensor types, especially the model level announced characteristic analysis not publicly available. And here are the general processing workflow for the intelligent interpretation of remote sensing images, which include the feature extraction, feature fusing, and the specific task network. For the typical tasks, it will include the image classification, object detection, image segmentation, and object tracking. And there are some basic idea or algorithms for the feature extraction, include the shift, the spin image, test tones, hog, glove, or rift. And with the application of the CNN algorithm, there are some algorithms based on the CNN, which will widely be used. And for example, is the LANet, XNet, VGG, ResNet, GlobalNet, and DenseNet. And the transformer is the basic structure for the feature extraction, and it includes the encoder, decoder architecture. The positioning encoder decoder is for the self of this diagram, and also for the feature extraction, there are some basic algorithms with VIT, PVT, REST, and the swing transformer. And here are some image feature extraction examples. And we also deploy this in the project's algorithms. Facing the challenges of the target recognition to recognize the complete shape target due to the occlusion, camouflage, and the dense smoke and the fog presents a complex background. So we propose the algorithms with feature extraction network based on the mass image modeling. It's called MAM. And firstly, we will build the mask encoder and then use the VIT model to analyze the global relationships in the images to interpret the target and decode the mask locations. And finally, the autoencoder retractions of the complete images from the mask version. And with the usage of these training models, and this result has been significantly to improve. And there are some algorithms for the feature fusion with FPN and BIPN, and with the challenges of the standard IPNs with complex backgrounds and also skill changes in remote sensing, including the noise that blurs the background, and then we proposed the GMM enhanced feature fusion for the remote sensing, and this method improves the Gaussian mixture model to fit the target features and enhance the target features, reduce the interfaces from background noise, and increase the model's focus on potential regions of the interest. And this one shows the result for these algorithms. With remote sensing image object detection and fine gained recognition, we also proposed the algorithm called TOSO, a single stage rotated object detector based on student T distribution, and it's introduced a novel geometric transmission method that generates an oriented bounding box from the surrounding horizontal bounding box. And for the another algorithms, we introduce the angle-free single-stage rotated object detector based on the interactive branch network. And the core of this one is interactive enhancing model, a self-attention based component, which can enable the interaction between the classification and the regression branches to improve the detection. And here shows the results of these algorithms. And another algorithm is called adaptive sample assignment strategy based on the elliptical distribution, which can reduce the wide variations in the target size and the shape, and also in adaptation of the unbalanced sampling for the objects with extreme size or the round shapes. And here are the high resolution remote sensing image segmentations examples, which are used widely in the land use classification, intensive segmentation in remote sensing, land cover feature extraction, and cloud detection, and also the land change detection. For the high resolution remote sensing image segmentation, we also to build the data set, which include the port, airport, commercial area, residential area, industrial area, and rural area. And also to give the semantic segmentation this boundary attention mechanism to give the model parameters fine-tuned by examining the visualization results of the boundary contrast and the tension models. And for the challenging of self-attention mechanism in the remote sensing images segmentation, which helps to long-range dispensing and capture global context, but it is computationally expensive. So we propose the algorithm called LDCNet, a lightweight dual range context aggregation network for the semantic segmentation, which can help to do context aggregation model with the simple and lightweight decoder to employ it to the integrate information from the different layers. And this is shows the result, and we also get the currency and computational efficiency. And for the patriotic segmentation, we also have the algorithms, and this shows the results for the patriotic high resolution for the remote sensing images to segmentate the building, the improved surface, the barrier land, the vegetation, the water, the taxiway, the railway, and the other kinds of targets. And here are the algorithms, and with the AI use and the remote sensing images are quite affected by the AI technology. And here's my honor to share these algorithms, and I hope that for the future remote sensing satellites like VRSS-3, we can use these technologies in these new projects. And thank you for your listening, and I hope that we can cooperate in the future.